Back to chapter 10. Section 5 this time is on tangents. What is a tangent? We'll find out. Okay, so we need to learn how to use the properties of tangents and solve problems involving circumscribed polygons. You need to remember what that word means. So here's some new words: tangent and point of tangency. What is a tangent? Not a fit that a toddler throws, but with respect to geometry, it's a line that intersects the circle at only one point, which means it has to intersect the very outer part of the circle. So this is just one point here. Obviously, we can't draw it. A point is way too small. Remember, a point actually has no size. So it's just the very, 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 very smallest intersection there. And this line would be called a tangent. It goes on in both directions forever. Here's a circle. Remember our parts. This would be your radius. What would this be called? Diameter. What is this called? Chord. If it goes through the circle at 2 points, notice there's 2 points of intersection here. It goes actually through the circle. That is called a secant. And then the one that touches at just one single point, this is called the tangent. And that point at which it intersects or it touches the circle is called the point of tangency. Point of tangency. When a radius hits a tangent at that point of tangency, you get a right angle. Okay, so we have a theorem that says that. The tangent theorem. It says a line is a tangent to a circle if and only if it is perpendicular to the radius at its endpoint, the radius's endpoint on the circle. So if you have these two things come together, the radius and the tangent, they will form a right angle. That can be helpful in solving for some unknown values there. A radius and a tangent intersect at a right angle. If there is a right angle intersection to your radius, then we know it's a tangent. So you can say it backwards or the converse, where converse means backwards. So here's some examples. If I have this picture and I know that RT is a tangent, then I know that OR is going to be perpendicular. Remember, this symbol means perpendicular. Therefore, it is a right angle. To say that backwards, if OR is perpendicular to RT, we see that in this right angle box, then we know RT is a tangent. So we can use the same relationship two different ways. Let's use it here in this example. Okay, if I know that RS is tangent, then I know this angle right here is a right angle, therefore this becomes a right triangle. I can then solve for QR using a squared plus b squared equals c squared. Again, I notice that this is 4 times 4. This is 5 times 4. Therefore, this is a Pythagorean triple, and this side would be 3 times 4, which is 12. You could do it out using a squared plus b squared equals c squared. You can work it out that way. You'll still get 12. So if you start learning to recognize these Pythagorean triples, especially 3, 4, 5, that is the most common one. It can save you so much work. If QR being a radius is 12, then QP being a radius is 12. Therefore, Y would be how much? 24. Okay, so this is all just an explanation. If you want to read through it. Okay, here is the actual working it out using Pythagorean's theorem. Notice you still get 12. You need to double your 12 and get 24. Okay, here's another one. CD. CD is a tangent, so I immediately know to draw this right angle box. If AD, this entire diameter, is 40, what is BD, the radius, going to be? 20. Is this a Pythagorean triple? Am I multiplying two different numbers here by the same number? I'm multiplying 4 by 5 here, and I'm multiplying 5 by 5. So if this is a 3, 4, 5 Pythagorean triple, I would multiply the 3 by 5 and get 15. So A is 15. Example 2. Determine whether BC is a tangent. Well, if it is, then this would be a right angle and this would be a right triangle. So I could say that 7 squared here plus this whole line would be how much? 7 and 7 is 14 squared would, oops, messed up. That's my hypotenuse. Let me erase it. It'd be 9 squared here, and that's going to equal the 14 squared. Okay, so I got that by squaring each leg. AB squared plus BC squared is going to equal AC squared, plugging in the numbers here. Now I got to square everything. 7 squared is 49. Do this out here. Plus 81, which is going to give you 130. But 130 is not the same as 14 squared. It's not 196. If this is not a true statement, this is not a right triangle. We set it up like it's a right triangle to see if we get a true statement. That doesn't mean it is a right triangle. We're testing it. So because the converse of the Pythagorean theorem did not prove true in this case, triangle ABC is not a right triangle. If it's not a right triangle, then it is not a tangent. Okay, determine whether WE is tangent. Same process. We're going to set it up as if it is a right triangle. Okay, so we're going to square the two legs, set it equal to the hypotenuse squared. Okay, square them, add them together, and you get 676. And if we square 26, we get 676. So is this a right triangle? Yes. Therefore, this is a right angle. Therefore, WE is a tangent. Okay, so we're pretty much just testing to see if they make a right angle. If they do, then EW is a tangent. As long as WD is a radius, EW had to be a tangent. Okay, set this one up. You do it, pause, see what you get, and then check your answer. Okay, so pause the video and work it out. Okay, so what'd you get? Should have gotten A, yes. If not, you need to go back and work it again, figure out what you did wrong. Troubleshooting will help you learn more than just listening and letting somebody else do it all for you. Here's another one. Practice again. Pause the video, work it out, come back and see what you got. Okay, did you get yes, no, or can't not be determined? You should have gotten B, no. If you didn't get that, go look at your work, see where your mistake is. If you can't find it, come talk to me. Ask it in class. Okay, some other relationships. If two segments come from the same external point, so here's a point, external means outside. Okay, so it's outside the circle, and we have two segments coming from that same external point. If they are both tangent, which means they're both going to make this right angle with the radius, then they are going to be congruent. So that distance is the same. So I could set up all kinds of problems here. Okay, so here's our external point. Again, the radii are congruent, right? This distance and this distance are the same. So AC and AB are the same. Okay, so let's use that here. Find x. Assume that segments that appear tangent to the circles are tangents. So we have two situations here because we have two circles. DE is tangent to circle S. DF is tangent to circle S. So that means DE is congruent to DF. So Y would have to equal 10. Pretty simple there. Well, in order to solve for X, I need to know Y. I got to plug that in. So if Y is 10, 10 minus 5 is 5. Okay. So now we have two more tangents. We have DG all the way to circle T and DH all the way to circle T. They're still tangents from the same external point, so they will be congruent to each other. How long is DG? If this portion is 10 and this portion is 5, the whole thing would be 15. That's going to equal the whole segment DH. DH is 10 plus x plus 4. So I have 15 is going to equal 10 plus x plus 4. Use our relationships to set up our equation. I combine like terms here. I get 15 equals 14 plus x. Subtract the 14 and 1 equals x. Does that answer the question? It says to find x. Yes. Okay, so this is a bunch of writing explaining what we did. Going through the steps. Okay. Don't really need to go through it again. Okay, let's see if we can think this through. We're wanting to find A. Well, here's our external point. We have three different tangents here, but they have to be to the same circle. So I can't just say 30 is congruent to 6 minus 4a because these two tangents are not to the same circle, but these two are. So 30 is equal to b. And these two are. 6 minus 4a is going to be equal to b. So therefore these two are. So I had to kind of go about it a roundabout way. You can't just assume it. You have to be able to prove it with the rules we already know. So we can set these equal to each other now. So negative 4a is going to equal, if I subtract the 6 here, it's going to equal 24. Now remember, if I divide by a negative, a positive divided by a negative is going to be a negative 6. It's okay for a to be negative as long as the whole distance is positive. Remember, distance has to be positive. So our answer should be D. Here's another one. Triangle HJK is circumscribed, drawn around circle G. So we could have a G here. Find the perimeter. Okay, well, if it's circumscribed, that means it's touching at one point in all of these intersections. So all of these lines are tangents. So we need to find the two that are coming from the same external point. So here's an external point H. H to L is going to be the same as H to N. They have to start at the same point. So this would be 18. K to N is going to be the same as K to M. And J to M is going to be the same as J to L, which is going to be 16. Okay. Now they tell us up here that NK equals JL plus 29. So this is JL, which is 16, plus 29. So how much is that going to be? It's going to be 45. So if Kn or Nk is 45, Mk is 45. Now I can find the perimeter. What does perimeter mean? Oh, know these words. It's the distance all the way around. So I would just simply add all of these up to get my total perimeter. 34 plus, let's see, 55, 63 plus 61. It's easier for me to do 3 of them there than to do 6 of them. 8. Okay, I get 158. Okay, again, we can do it a lot neater using the computer. Plug it all in. And then add them all up. You get 158. Okay, so look at it again. You're coming from the same external point. So all these tangents coming from the same external point are going to be congruent to each other. 18 and 18, 16 and 16. Okay, it told us up here that NK was JL plus 29. That's where this came from. If this is 48, this is, or 45, this is 45. Add them all together and you get 158. Okay. Triangle NOT is circumscribed about circle M. Find the perimeter. If CT is NC plus 28. So I'm just going to go in here and I'm going to mark all the ones that are already marked. I know the opposite side is going to be congruent. We know that CT here is NC, which is 52, minus 28. So 52 minus 28 is what? 24. So this is 24. So add them together. 34, 44, 96, 148, 172. If you add them all together, C. Okay, last thing. We have two circles. They have the same tangent. This is called a common, meaning the same. External, meaning the outside. So if you were asked to draw a common external tangent, you would draw two circles and have that tangent going between the two circles, touching at one point on the same side of the circle. If you want an internal tangent, it's got to cross through the middle. So this is a common internal tangent. I just want you to know those two terms. Internal means inside. It has to go between the two through the middle there. External has to connect the two on the same side. So what would this one be? External or internal? It would be external. Okay. And you could draw another internal tangent if you wanted to, crisscrossing this way. That wasn't a very good tangent, as it should only touch at one point, but you get the idea. Alrighty.